platform. And we make use of a combination of virtualization of devices. So, domain 0 will typically have device drivers in for a variety of devices. For example, typically we'll have device drivers for things like the SATA controller and the disk. Also for the network interface and wireless drivers. But some devices will actually make use of pass-through, PCI pass-through, and pass them through to a particular virtual machine. And the in the example we've got here, we're passing through the GPU through that virtual machine. And also, obviously, individual USB devices can be passed through, so that we would use the driver in within the virtual machine. So, as an example of how you might use this, you might provide two virtual machines, one personal and one business. So, obviously, the personal virtual machine, the user is free to install their own applications. They can install iTunes, Instant Messenger, or whatever it is that they want. But the corporate IT department would then provide this business virtual machine, which would be very tightly locked down, perhaps more locked down than it would be if it was a, than if they weren't providing the personal virtual machine, because the users would not put up with it being locked down so tightly. So one of the things you can even do is to make it so that whenever the business virtual machine reboots, it actually gets reset, the system disk image gets reset to some known pristine gold image state. So if any malware has managed to attach itself to the virtual machine, it will just get cleared away whenever you reboot it. And so this can all help to greatly improve the security of the platform. So I was going to do a demo here, but as soon as I managed to crash my laptop, after Keir's given his talk, I'll do a few demos. So now we'll talk about the cloud platform. So the Xen Cloud Platform really expands the remit of Xen.org, which previously has been concerned with just building the core hypervisor, whereas now we're actually trying to build a common platform which vendors can choose to adopt to implement a full virtual infrastructure layer to enable cloud deployments. So today, what happens is all of the various hosters and and other vendors and cloud providers, they take the core Xen engine and then add a whole bunch of stuff to it. So typically they'll need to pick a kernel for running the various device drivers in domain 0, and they could pick Linux or BSD or Solaris. And then they have to have a tool stack and domain 0 file systems. There's a lot of different variation between what the different providers pick. And what we wanted to do is to really try and create a reference implementation that vendors could pick up and use as a sort of an off-the-shelf unit if they so wish. And so this should make it easier for for cloud providers to pick up Xen and to start using it. Also, what we hope this would do would promote greater standardization of components, so that more of the energy of the community would be focused on perhaps a smaller number of Linux versions, or perhaps even on the same kernel, and that would help the development move faster by having that greater focus. And also another key aim is to promote more interoperability between the various vendors' implementations. But a key goal is to really advance the kind of service which cloud providers are able to offer today. Because cloud providers today are really offering virtual private servers. So this is an individual server which will be out, out on the internet with a public IP address. And that's great if you want to run something like a web server, a simple application like a web server, or if you've got something like a computational job that you can just package up and then run on one of these virtual private servers. But it's not really very flexible. It doesn't provide you the same kind of flexibility that enterprises would have within their own corporate data center. And that's really what we want to enable, is this move from virtual private servers to virtual private data centers. And what that means is that rather than just having a single virtual machine, you have some set of virtual machines, and you get to control the topology and configuration of things like the storage and networking of that set of virtual machines. So, for example, we could create our own internal private network between a set of virtual machines that would be part of a virtual private data center, so that we wouldn't have all of these virtual machines having exposed public IP addresses. And we can build our own rich network topologies and also get control over where the actual storage for those virtual machines is going, so that we can actually provide some kind of quality of service and reliability guarantees. So there's a lot of work to do in the Xen community of providing these multi-tenant hosts, multi-tenant networking, and multi-tenant storage with the right kinds of performance and quality of service guarantees. Another aim of the Xen Cloud Platform project is to promote interoperability, not just between Xen-based clouds, but also with clouds from other proprietary vendors. And part of the aim there is to actually be far more active in the various standardization bodies than perhaps as a community we have been to date. We've been quite passive in observing what's happening in things like the DMTF. But I think that there's a lot more that we can do to really drive the agenda there, because Xen really leads in many of these respects to do with networking and storage. We have and also, being open source, we have a great open reference implementation that people can pick up. And that's as everyone knows, the only way that you can really get standardization is by having an open reference implementation. If you just have a written down specification and everybody goes away and implements it, nothing ever actually manages to talk to each other. If you have an open source implementation, then you can actually make real progress. So the Xen Cloud Platform announcement happened in August, and there are all of these various vendors representing different layers of the hardware and software stack that participated in that announcement. And so the status of the project is really still at the stage of, or continuing to seek proposals from companies about code that they can contribute, perhaps code that they already have, that they can contribute to the Xen Cloud Platform. And also there have been many offers of development support from companies that have wanted to add particular features or support particular platforms. So all of that information is being pulled together on the various Xen.org wikis and getting that website up to date. Also now we do have a draft implementation. This is just pulling together all of the various bits of software that those companies, particularly Citrix, have open sourced and made available for use on the Xen Cloud Platform. So if you go to the Xen.org website, there is a 0.1 proposal which can actually be downloaded and played with, and it's a complete install ISO. So you just download the ISO, burn it onto a CD, pop it into a server, power it on, and 5 minutes later you've got a Xen Cloud Platform node that you can start to use. And of course all of the source for that is all available on the Xen.org website. And there's already